In this orthokeratology case, the patient's lens is showing decentration over time. It's going down and out on this left eye, and you can see the cornea is a little bit decentered itself, and the lens just following the contour of the anatomy. So sometimes it's difficult to completely correct these cases with a very well-centered treatment, but one thing we can try is to adjust the peripheral sag. See if we can kind of nudge this lens towards the visual axis a little bit more. So if you look at the picture representation of the back surface curvature, you can always see that down in this outer lower quadrant, the lens already has a higher sag value. You can see the steeper curves to match the contour of the cornea. So one thing we can do is kind of exaggerate that a little bit, and we'll go ahead and go down into this quadrant. We'll make this change in 25% mode. And we can see our sag values are 817 and 1922. What I would try doing is tighten the lens here at the blue control point, increase sag here, and then leave the edge as it is. So we'll bump this 15 microns and bring it up to 832, and we want to leave this 1922. Went a little bit over. And then changing the blue also changed the edge, the pink control point, so we need to come back out here and readjust that. And if we bring up the display, then we can see we're pretty close to target. One click bumps it 2 microns in this particular scenario, so we'll just go with 1923, 832 in the blue. And we can make the opposite change in the opposite meridian. So in this one, we want to make the lens a little bit flatter. We want to decrease the sag. And again, I think we can leave the pink alone, or maybe decrease that a little bit. So we go 15 here. Let's decrease by 7 here. So our new targets will be 787 and 1800. $17.87. And 1800. Lens does look a little bit weird, but if this is what works, then I think most of us will take the good result over a nicely laid out simulated fluorescein.